Welcome to the video lecture on exponents.
This hopefully should be a review for most of you. If you have a positive integer exponent, you solve it simply by taking the base value of the exponent, in this case a, and multiplying it together the number of times for the exponent. So in this case, it would be n times. If you have an exponent of 0, it does not matter what the value of a is. That expression evaluates to be 1. Notice the notation here that upside down capital A is a symbol which means for all. So you would read the expression here, a raised to the 0th power equals 1 for all values of a. If you have a negative integer exponent, all that means is that you need to take the reciprocal of a to that power. Now in this case, we're acting as if a is an integer, but this is true even if a is a fraction. So for example, if you had 2/3 raised to the -2, you would take that to be 3/2 raised to the 2nd power. Finally, if you have a fraction in the exponent itself, so if you have a raised to the power n over m, what it means is you need to take the mth root of a raised to the nth power. So for example, if you have a to the 1/2, that means that you are taking the square root of a. With exponents, really the best thing to do is to practice. So we're just going to write out a few different expansions for these different examples. So 5 cubed is simply going to be 5 times 5 times 5. 5 to the 0th power is going to be 1 because anything to the 0th power is 1. 5 to the -7th power is going to be 1 over 5 to the 7th power. And 5 to the 2/3 is going to be the 3rd root of 5 squared, which is 25. -3 to the -1, don't let the negative sign on the 3 throw you off. All that's saying is you need to take -3 in the denominator. If you have -3 squared, that's the same as saying 3 squared and setting it equal to 9. I almost always, if I have a complex expression and I have a negative sign raised to an even power, will simply eliminate the negative sign because it's redundant and the positive exponent is going to be equal to the same value. That way I don't make any sign mistake later on in the process. If you have -3 to the 1/5, that is the 5th root of -3, which would be an imaginary number. And finally, if you have -3 to the 0th power, it's equal to 1. Moving on, if we have 2/3 to the 0th power, it's equal to 1. It's true for all values of the base of the exponent. If you have 2/3 to the -2, remember the negative sign for a fraction is going to mean that you need to take the reciprocal. So here that's 3/2 squared. If you have 2/3 raised to the 2nd power, that means that you can distribute the 2 down into the fraction and get 2 squared over 3 squared. And finally, if you have the fraction 2/3 raised to the fraction -3/2, there are really 3 things you're going to do. The first is take the negative sign and use it to get the reciprocal of the fraction so that you get 3/2 raised to the 3/2 power. You're then going to recognize that the fact that it's 3/2 means that you need to take the square root of 3/2 cubed. So go ahead, take a moment, pause the video and work through each of these to find a different expression for each of the exponents. Now take a moment, just verify that the values you got when you did the problems match the values you see here. Next, we're going to talk about algebraic manipulation of exponents. The first is the concept of equality, which is that if you have a raised to an exponent and it's equal to the same value raised to a different exponent, that means that those two exponents are equal to one another. You can eliminate the a's and just say that x is equal to y. If you have two exponents multiplied together with the same base value, you can take the base value to the exponent x plus y, so adding the two exponents together. If you're dividing the same base value with two different exponents, you take that base value raised to the numerator's exponent minus the denominator's exponent. If you have an exponent raised to another power, you're going to multiply the two together. If you have a product that is raised to an exponent, you can distribute the exponent into the product as shown here. If you have a fraction raised to an exponent, similarly, you distribute the exponent into the fraction. So now to do a few examples. In the first case here, we have the same base value, 5, multiplied by 5 to the 4th times 5 to the 3rd. So we can take 5 raised to the sum of those two exponents. In the next case, it's sort of the same thing. We have the same base value, 1/3 raised to the 3rd times 1/3 squared. We take that 1/3, raise it to the sum, 3 plus 2. We can also distribute that 5 into the fraction if we want to, so that it's just 1/3 to the 5th. For 5x squared, we can distribute the squared into the parentheses so that we get 5 squared, or 25, times x squared. In the next problem, we have the same base value, 5 cubed over 5 squared, so we will take 5 raised to the power 3 minus 2, which is just 5 to the 1, which is 5. In the next problem, we see basically the same thing. We have one base value, 1/4, raised to the power 7 over 1/4 to the 2nd. To solve that, we take 1/4 raised to the power 7 minus 2, which is 1/4 to the 5th, and if we want, we can distribute that 5th into the fraction so that we get 1/4 to the 5th power. For the next problem, we have an exponent raised to another exponent. So in this case, we multiply the exponents together. We get -3 raised to 4 times 2, which is -3 raised to the 8th. Because this is an even exponent, I'm going to simplify by eliminating the negative sign, because that's going to be equal to 3 to the 8th. All right, for the next problem, again, an exponent raised to another exponent, so we multiply the two exponents together. We get 10 to the 2 times -3, or 10 to the -6th, which is the same as 1/10 to the 6th. We have 3/4 cubed. We will distribute the cubed into the parentheses. We get 3 cubed over 4 cubed, which we could expand out if we wanted to. In the next problem, we have the same base value, -2, times raised to the 4th times -2 to the -3rd. Recognize that this is actually just -2 to the 4th over -2 cubed. Either way, you get -2 raised to 4 minus 3, which is -2 to the 1st power, or just -2. In the next problem, we have -3 over 2. So we'll over -3 to the 6th. So we will take -3 raised to the power 2 minus 6, or -3 raised to the -4, which is 1/3 to the 4th power. Here we have the base value 6x raised to 3 minus 8, or to the -5th. And we can rewrite that as a fraction, 1/6x to the 5th. And finally, we have 8y squared. We will distribute the squared into the parentheses to get 64y squared. It's your turn. So pause the video at this point, work through these practice problems, and then we'll come back and check your answers. And here you are. Take a moment to check your answers. And at this point, you are done. I will see you soon.